students, you are welcome to Dr. OJ's tutorial class. In this video, we want to talk about domain and range of rational functions. Domain and range of rational functions. This is a kind of special review on this topic because we've done it before, but based on popular demand, I decided to go into more details about domain and range of rational functions. This is a very good example of rational functions. Functions that have numerator and denominators. Functions that exist in form of fractions are called rational functions. And now when we say domain, what do we mean? Domain means the input values of a function, while the range means the output value of a function. So by domain we mean the set of x values. What are the values of x in this particular function? That is what we are asked to find. Okay, now looking at this function, the very first thing that should come to mind is what? Is the denominator. Because if this denominator is equal to 0, then the whole function will be undefined. It means that we have x squared minus 4 all over 0 will be infinity. Now, and that should not be, because x must exist. Now, for x to exist for x, or for the function, let's say for the function to be defined, x squared minus 9 must not be equals to 0. Okay, so we have x squared minus 9 greater than 0 for that function to be defined. But however, let us exclude x that will be undefined. However, if x squared minus 9 is equal to 0, what will happen? Okay, we have, factoring this, we have x minus 3, x plus 3 is equal to 0. So from here we have what? X minus 3 equals to 0, or x plus 3 equals to 0. Okay, so with that, x will be equal to 3 or minus 3. With that, x will be equals to 3 or x equals to minus 3. That means for this expression to be undefined, x will be 3 or minus 3. Now, that means x equals to 3 or x equals to minus 3 must be excluded. Because if it's included, the expression will be undefined. So what do we now do? Okay, we want to exclude x equals to 3. For all other values of real numbers, this function will be defined, except for x equals to 3 or x equals to minus 3. On the real line, let's say this is 0. The negative side is minus infinity. The positive side is what? Plus infinity. Okay, but at x equals to 3 and x equals to minus 3, these values must be excluded. Okay, so that means the domain of f of x, is now equal to, it will be minus infinity. Okay, now minus 3. I wrote minus 3 here. I didn't close it. That means minus 3 is not included. Combine with minus 3 as well. 3, we are moving towards the right now. Union again. The terminal point here is 3, then plus infinity. So that's the domain. So this is the domain of that function. You can see it ranges from minus infinity to infinity. And note that minus 3 and 3 are not included. If they were included, the bracket will be square bracket. But because they must not be included, so it will be simple bracket. Now we move to the range. We move to the range of the function. To get the range of the function, we are invariably looking for the values of y. That is, to find the range could be found. So, f of x is equal to x squared minus 4 all over x squared minus 9. Now, to find the range, we are going to look at the entire function must be equal to 0, must not be, must not be 0, must be equal to, must be greater than 0, sorry. Now, it must be positive as well. What we need to do is that let's divide the numerator and denominator by the highest degree of x. Okay, so we have x squared all over x squared minus 4 all over x squared all over x squared all over x squared minus 9 all over x squared. We want to find the limits of x as of the limit of the function as x tends to 0, so as to know the particular value of y that must, lie in that particular, that particular function. Okay, because we are actually concerned with the horizontal asymptotes. That is, as s tends to plus infinity or negative infinity, what do we have? What do we have? Let's see. That is limit of this. Now we have limit x tends to infinity of this. We have what? 1 minus, because this is 1, 4 all over x squared. This is 1 minus 9 all over x squared. So as x tends to infinity, what do we have? We have what? 1 minus 0, because 4 over infinity squared is 0, all over 1 minus 0. So everything is 1 over 1, which is 1. So that means the horizontal asymptote here is at y equals to 1. That is the horizontal asymptote. The horizontal asymptote at y is equals to 1. Remember, the range of a function is the value of your y. So now, that means that y must not be equals to 1. That's what it means. Y must not be equals to 1. That is, the range of this function must never be 1. It can only tend towards 1. It can never be 1. That is the meaning. It can never be 1. So now, how do we find the range? Fine. The range, therefore, of f will be minus infinity, 1 union 1 infinity. Okay? That is what? That is the range. It must never be 1. It must never be 1. It could be negative infinity. It can't be 1. If it were 1, this will have been square bracket union 1 infinity. So it's lying between negative infinity and positive infinity, but it must not be equal to 1. So let's look at another example. So that is that about that. 1 is being excluded there. 1 is being excluded. Now example 2. Example 2. Example 2. Find the domain and range of the function. And range of the function g of x is equal to x squared plus x minus 6 all over x squared plus x minus 2. Fine. Just like the first example, for us to find the range and domain, we have to follow closely the steps. Now, to find the domain, that means we want to find the values of x for which this expression is defined. So for this expression to be defined, x squared plus x minus 2 must be greater than 0. If it is equal to 0, the expression will be undefined. However, if x squared plus x minus 2 is equal to 0, we want to find the values of x for which the expression will be undefined. So if we are able to get the value of that x, we remove it out from the real numbers. Then that will be the domain. The domain is the set of x values, the set of input values, the set of x values. So if you are able to get those ones that will give us undefined value, You just exclude them from the real numbers, then that gives us the domain. So we can factorize this expression. We factorize, we have x squared, let's say I'm looking for minus 2x plus 2x minus x minus 2 equals 0. So x into x plus 2 minus 1 into x plus 2 equals 0. So x minus 1, x plus 2 equals 0. So that means x minus 1 equals 0, x equals to 1. X plus 2 equals 0, x equals to minus 2. Okay, now that means that this expression, this rational function, this function will be undefined when x is equals to minus 2 and 1. Fine, minus 2 and 1. But this minus 2 and 1 must be excluded for the expression to be defined, because what we are actually looking for is the value at which x is defined. The value at which x is defined. So minus 2 and 1 must not be there. Must not be there. Okay. Therefore, now we exclude x equals to minus 2 and x equals to 1 from the real numbers. From the real numbers. From the real number R. Okay? Hence, the domain of f is a set of minus infinity, minus 2, union minus 2 again. Okay, 1, union 1, then infinity. Yes, that is the domain. So we have excluded minus 2 and 1. It is excluded there. It's a continuous, thing on the real line. And, when we get minus 2 here, we have to start with minus 2 again, because it is what? Disjoint. So 1, union 1, and infinity. So it's moving from minus infinity to infinity. So let's look at the range of the function. Let's look at the range of the function. Following the earlier procedure that we used, you can get the range of the function. Following the earlier procedure. Now, what's the function again? The function is g of x. Okay, g of x. G of x is equal to x squared plus x minus 6 all over x squared plus x minus 2. Fine. Now, using the earlier procedure, we want to find the limits as x tends to infinity of this function. Okay, let's see. That's it. X squared all over x squared plus x all over x squared minus 6 all over x squared. Everything all over x squared all over x squared plus x all over x squared minus 2 all over x squared. Okay? Now we're trying to find the limit as x tends to infinity. Well, that's the procedure we're dividing. Whenever you are dividing by the highest degree of x, it means you are finding the limit of x as x tends to infinity. That's what we are trying to do here. That is, limits as x tends to, it could be plus infinity or minus infinity. All this is the same. So that will be what? Limit of, because this is 1 plus 1 over x, this is 1 over x, minus 6 all over x squared, all over 1 plus 1 over x, minus 2 all over x squared. Okay, so that is just saying that 1 plus 1 over infinity, that's what we are saying, minus 6 all over infinity squared, all over 1 plus 1 over infinity, minus 2 all over infinity squared. So 1 over infinity is 0, 6 over infinity squared is 0. So we have what? 1 plus 0 minus 0 all over 1 plus 0 minus 0. So it's 1 over 1, which is 1. So that means the range of this function must never be 1. And this, as s tends to infinity, the range must not be 1. So that's when y is at horizontal asymptotes. When x tends to infinity, y must not be 1. So what follows now? What follows? Therefore, the range of the function f of g, sorry, our function is g here, is what? Minus infinity union 1 plus infinity. Can write infinity alone. So that is the range of the function. That's the range. Now the last one here, the last example. Let's quickly look at the last one. The last example. That's example 3. Example 3. Find the domain. Find the domain and range of the following. Find the domain and range of the following. H of x equal to x squared plus 1 all over x minus 2. Fine. Now, without wasting our time, this expression will be undefined. The h of x will be undefined if x minus 2 equals to 0, which implies that x will be 2. So, if x minus 2 equals 0, x will be 2. By the time x equals to 2, this expression will be undefined. But we want the values of x for which the function is defined. So that means we have to exclude x equals to 2. So we remove x equals to 2 from the number line, from the real numbers, for g of x and for h of x to be defined. For it to be defined, we have to remove. So that means our domain can be all other real numbers except at x equals to 2. Except at x equals to 2. So therefore, domain of g of g of x is what? Minus infinity, 2 union 2 infinity. So that is the domain of the function. Now, how do we find the range? How do we find the range? Using our usual method of taking the limit as s tends to infinity. Let's check. We have what? H of x is equal to x squared plus 1 all over x minus 2. Now, to find the range, let y equals to x squared plus 1 all over x minus 2. So by the time you cross multiply, you have, that's the method. You'll be wondering, why don't you take our usual method? You observe that x squared is not found in the denominator here. It is found only in the numerator. So we are going to adopt another method. Had it been we have x squared here, we will have divided our numerator and denominator by x squared, as we have been doing before. But because the numerator has a higher degree than the denominator, so we have to apply another method. So we now use y to replace h of x. H of x is the same thing as y, So cross multiply, we have y into x minus 2 equals to x squared plus 1. So by the time we expand, we have what? Yx minus 2y is equals to x squared plus 1. Okay, so taking it to the other side, we can have x squared plus 1 is equals to yx minus 2y. which will become what? X squared minus yx plus 2y plus 1 equals to 0. So we can have it like saying that x squared minus yx plus into 2y plus 1 equals to 0. So this has given us what we call a quadratic equation. A quadratic equation of variable x. Yes, so we can factorize this. We want to find the value of x here, So using quadratic formula method to find x, okay? So that is x equals to plus or minus square root of b square, sorry about that, minus b plus or minus square root of b squared minus 4ac all over 2a. So let's fix them up. Let us fix them. How do we fix this? Fine. Our b here, is y. If you compare this with ax squared plus bx plus c. C is the whole of this. These are constants. So b is minus y and a is 1. So we have x equal to minus y, okay? Then plus or minus square root of y minus y squared minus 4 times 1 times our c is 2y plus 1, 2y plus 1 all over 2 times 1. This will be what? Y plus or minus square root y squared minus 4 into 2y plus 1 all over 2. So we can expand that. So let's now take, the values in the square root must not be negative. Yes, for our expression to be defined, because we are dealing with rational numbers which are of real values. We are talking about real rational numbers. So this value in the bracket must not be equal to 0. So the value in the square root, note, y squared minus 4 into 2y plus 1 must not be equal to 0. And it must not be negative. Okay? It goes to 0 anyway, because 0 is a positive value. Must be greater than 0. Let's use that statement. Yes. So you can equate it to 0 because 0 is still positive too. So we have y squared minus 8y minus 4, let's say now greater than 0. Yes. So if we want to get the values of y, let's use greater than or equals to 0. So it covers that it could be 0, it could be greater. Both means it is positive. So that means we solve for y. Now we solve for y using almighty formula as well. You can see we are getting another almighty formula. Using the almighty formula, using y is equals to minus b plus or minus square root of b squared minus 4ac all over 2a. You can see we have just finished one quadratic formula method. It has also led us into another one. So that's how it is done. Okay. So we are particular about the one in the square root. We have to take the one in the square root. That's why we are picking this. So we have what? Y will now be equals to minus b. This is our b. If we are taking, let's say, ay squared plus by plus c. So b is minus 8. Minus 8 plus or minus square root of minus 8 squared b squared minus 4 times a is 1 and our c is minus 4 all over 2 times our a is 1. So y equals to 8 plus or minus square root 64 plus 16 all over 2. Yes. So With that, 64 all over 2. So we now have y is equal to 8 plus or minus square root 80 all over 2, which will be 8 plus or minus square root 16 times 5, I think that's 80 all over 2, which will be y equals to 8 plus or minus 4 root 5 all over 2. Because square root of 16 is 4. Okay, which is 8 all over 2 plus or minus 4 root 5 all over 2, which now what? 4 plus or minus 2 root 5. So that means that our range must exclude 4 plus or minus 2 root 5. Must exclude it. Okay? But don't forget, this time around, it is y that we have obtained. It means it will be included. We have automatically obtained y is equal to. You know, we obtain this y is equals to this, not from limit theory. Yes, if it had been obtained from limit theory, this value will be excluded. But y is not from limit theory. Okay? So for that reason, we will not exclude it. I hope you are getting it now. We didn't obtain this y through limit method. So therefore, our y, we have two y's now. Therefore, y equals to 4 plus 2 root 5 or 4 minus 2 root 5. So, since y is obtained, that is the range, not from limit theory, the value of y must be included in the range. Therefore, range of h of x, I think the value is the function is h. Okay, h of x will be minus infinity, yes, comma 4 minus 2 root 5 closed. Yes, you have to close it because it's obtained not from the, it's not obtained through limiting values. Union 4 minus 2 root 5, 4 minus 2 root 5, okay, we don't need to spread that, plus, because we don't need to spread it, it's not from limit theory. So that is plus infinity. Yes, that is the value of the range. That's the value of the range. So you can see that this is closed because 4 minus 2 root 5 is obtained as y, 4 plus 2 root 5. So we don't need to spread it again since we are not using simple brackets, since the values are in the range of the function. So they must be included. Our y was not obtained through limit theory. It was obtained directly from algebraic operation. So that is that. With this, we have come to the end of the domain and range of rational functions as given in this video. Do well to click on the notification button so that each time I upload a video, you'll be daily notified. Stay blessed.